Welcome to video 1 for this unit on functions and volume. In this video, we're going to focus on inputs and outputs. An input-output rule is a rule that takes an allowable input and uses it to determine an output. For example, this diagram represents the rule that takes any number as an input, say 3/4, then adds 1, multiplies by 4, and gives the resulting number as an output. For some rules, not all inputs are allowable, and the rule must specify which inputs will work. For example, this rule is fine when the input is 2, but if the input is -3, we would need to evaluate 6 divided by 0 to get the output. So when we say that the rule is divide 6 by 3 more than the input, we also have to say that -3 is not allowed as an input. Let's say we have a special type of input-output rule that for each allowable input gives exactly one output. Then we also say that the output depends on the input, or the output is a function of the input. A function is a rule that assigns exactly one output to each possible input. Both rules we have seen so far, add 1, then multiply by 4, and divide 6 by 3 more than the input, are functions. For a rule like the length of a rectangle with this perimeter, the input does not determine the output because knowing the perimeter of a rectangle does not determine its length. A rectangle with perimeter 16 inches may have a length of 1 inch and a width of 7 inches, or a length of 2 inches and a width of 6 inches. This rule is not a function. Let's look at a different rule that is a function. The area of a square is a function of the side length because you can find the area of a square given the side length by squaring it. So when the input is 10 centimeters, the output is 100 square centimeters. We can sometimes represent functions with equations. For example, the area A of a circle is a function of the radius r, and we can express this with an equation. A equals pi r squared. Recall that the radius in the area formula for a circle is the length of the line segment that goes from the center to the edge of the circle. Using the diagram to represent this function, we think of the radius r as the input and the area of the circle A as the output. If the input is a radius of 10 centimeters, then the output is an area of 100 pi square centimeters, or approximately 314 square centimeters. Because this is a function, we can find the area A for any given radius, r. Since it is the input of the function, we say that r is the independent variable. An independent variable represents the input of a function. As the output of the function, A is the dependent variable. A dependent variable represents the output of a function. Thank you for watching video 1 of 5 for this unit on functions and volume.